Welcome to our playground where you're about to embark on a wild ride exploring the bedrock of object-oriented programming. I don't care if you're just starting out in the world of programming or you're looking to level up your Python skills. Get ready and buckle up because we're going to break down the 4 pillars of OOP: encapsulation, inheritance, polymorphism, and abstraction. Welcome back, guys, to another episode of PyPod Chronicles. Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go. Guys, before I dive into this week's episode, the link in the description has, well, everything, okay? If you head on over to the link in the description, it takes you back to the blog where you get my free Python guide as well as my free Python course. And it's not just one course, it's actually 2 courses. Over 30 hours of premium content, absolutely free for you guys to get you started in your Python journey. Okay, so head to the links in the description. All my resources are there for you guys. So picture it like this. Encapsulation is like our reliable guardian of the code. It's like a trusty vault. It makes sure the code is safe and it holds its integrity. Inheritance, on the other hand, now this functions as our guiding compass. It's like a treasure map. It takes us through the classes, allowing them to work together, right? Polymorphism is our shapeshifter in the story, and abstraction is our storyteller. Well, let's dive into the 4 pillars of object-oriented programming. OOP is a programming paradigm that revolves around the concept of objects. In Python, everything is an object. I don't care if it's a number or a string or a custom-defined class, okay? Everything is an object. Now, before I go any further, right, you guys should already know, most programming vocabulary. If you're new here, that's what this podcast is for, so let me break it down real quick. I'm going to introduce some new lingo that hopefully you've heard before, maybe you haven't, all right? But remember these words. They're like vocab words. Going forward, a method is a function in a class. A property is a variable in a class. That's it. A method is a function, a property is a variable. Same, except they're in a class. But also remember, a method and a property must be connected to an object of its class in order to work. You can't run this method, this function, without being connected to its object. Okay, so let's brush through these. Encapsulation, right, guys? So encapsulation is really the cornerstone of the object-oriented design. Encapsulating data and methods within a single unit, a folder. This folder is known as a class. Now, encapsulation is like a protective bubble that wraps around an object, and it keeps the internal state and behavior from the outside world. Okay, so if you want to think of it like this way too, it's kind of like a cookie jar, because a cookie jar, you can access the cookies, the methods and properties, anytime you want, but they're all held inside one jar. So if we apply this to code, right, consider a class that represents a bank account. Encapsulation would allow us to hide the account balance and transaction history from external manipulation. So if you have a class that has like account number, account balance, transaction history, maybe you only want to view one of those on the outside, or you just want to keep them all private. I can create a class for this. Now, the second pillar of OOP is inheritance. And inheritance facilitates the creation of new classes using properties and methods of existing ones. So this really fosters code reusability, and it gives us that like hierarchical structure that we can really use in Python to structure our code, not only correctly, but make it more readable and optimized. Because let's face it, right? Python isn't the fastest language of them all, and we know that, right? But there are tips and tricks we can do to make our Python code faster. A quick analogy for inheritance is like a family tree, where characteristics and traits are passed down from your ancestors to you, right? We take attributes and behaviors from both of our parents. The same concept applies to inheritance. So if we carry on with our bank account reference from before, we have a class bank account. I could create 2 more classes. One could be called savings account, one could be called investment account. but they're both going to inherit the basic structure of our initial bank account class, right? Because in the end, they're really an account, just a special type of account. Okay, so I've already brushed on the first two pillars. Now, these two, right, if you're new to OOP, this is what you need to be working on. The next two, right, not yet. You're gonna get into that and you'll see how they play into each other as you expand in your journey and like your projects, okay? So really focus on encapsulation and inheritance, because without these two OOP concepts, going further becomes difficult. If you've gotten down these first two pillars, right, let's take us into the third pillar. This is called polymorphism. And polymorphism is actually the Greek meaning of many forms, allowing objects of different types to be treated as objects of a common subclass. And the word itself, polymorphism, that could have been a city in Greek mythology, like a getaway island for our buddy Zeus and his palace. Imagine this scenario, right? Imagine we have classes that represent different shapes: circle, square, triangle. The only thing that these shapes have in common is the fact that they're all shapes. That's it, right? So what could we do with the shape though, right? They might have area, but it's calculated differently. They might have a perimeter, but it's calculated differently, right? With polymorphism, we could define a common function, not a method, a function, one function on the outside of these classes called calculate area, which behaves differently, and it's given an object, it's given a shape, and then we can link that to an area method, right? Because each shape still has an area method. And guys, if you want this broken down, I have a video on this on my YouTube channel, Code with Josh. Head on down there, as well as a bunch of other videos to help you in your learning journey. Our final pillar is known as abstraction, and abstraction is about focusing on the essential qualities while hiding unnecessary details. In Python, we can achieve abstraction through abstract classes and methods. Now, an abstract class defines a blueprint for other classes, but it cannot be initiated on itself. Abstract methods, on the other hand, provide a guideline for a subclass to implement their own unique functionality. So, okay, here's how I remember it. Here's what I tell myself. If you remember the polymorphism example, right, we have three classes: circle, square, triangle. Well, now for abstraction, I could create an even higher class, and let's call it shape, right? All three of those, square, triangle, circle, is a shape. So really my abstract class is like a reminder that any method in this reminder, this abstract class, if you inherit this class, you must complete these methods, right? So in my ABC, my abstract base class, so shape, I might create or define a method called calc area. But inside the definition of this function, I'm just going to put pass. I'm going to skip it. And then I create a shape called triangle. Triangle inherits my abstract base class, shape. Now I must complete calculate area inside triangle, right? Because each shape calculates the area differently. Okay, so when do you use encapsulation? You should use this in situations where your data or methods within an object need to be hidden from the outside world. Okay? Encapsulation also promotes modularity by allowing changes to be made to the internal implementation of a class without changing those outside components. When do you use inheritance? Well, inheritance is particularly useful in scenarios where you need to represent is-a relationship between classes. Right, so we have bank account, but then there is a savings account, there is a checking account, there is an investment account, right? They can all inherit from one initial class. This promotes your code organization, but also reusability by reducing any redundancy you might have in your code. The third pillar, what was it again? What was it? Polymorphism, right? Much like its counterparts, it's a powerful tool in object-oriented programming. Polymorphism helps you write code that adapts to diverse requirements and scenarios. Okay, so it's a function, how I like to think about it. It's a function outside a class that takes an object that calls a similar method within a class. And finally, abstraction. You can use abstraction when you need to simplify complex systems by focusing on the essential features, all while hiding unnecessary implementation details, because abstraction allows you to create models that capture the core aspects of your system or concept without getting bogged down by the intricacies of the internal workings. If you boil it all down, you can use abstraction when there is a need to manage. So when you need to create reminders to complete something at a later stage, abstraction. Mastering the 4 pillars of OOP and how they build on each other is an essential part for not only crafting your code and all that gibberish, right? It's an essential part for building your logical thinking skills and furthering your journey in programming, not just Python, any language, okay? You spoke about, I did, actually, not you. Encapsulation, right? This is really just a folder that's holding variables and functions, properties and methods. Our second pillar is inheritance. Inheritance is when we give existing properties and methods to a new class. That new class can expand and create ones of its own as well. The third pillar of polymorphism empowers objects to inhibit multiple forms. So I have 3 classes. They each have a method called deposit money. I then create a function that takes an object and then links an object to a function called deposit money, polymorphism. And abstraction encourages us to focus on essential features while hiding any unnecessary implementation details, right? ABC, abstract, base, class. In conclusion, guys, the 4 pillars serve as the cornerstone of modern software development, not in Python, in programming. By understanding and applying these concepts, you're going to unlock the full potential. I hope you guys enjoyed this week's episode. Guys, remember the link in the description. Head on down there. There are all my resources free for you guys. Thank you guys for tuning in for another episode of PyPod Chronicles. And I will see you guys in next week's episode. Until then.